Here we're going to prove by contradiction this example that for all integers a and b, if a squared plus b squared is odd, then a is odd or b is odd. All right, so let's start by just reviewing our hypothesis and our conclusion because we do have an if-then statement that we're trying to prove. So this part right here is our P, or our hypothesis. Here we go. And then the second part, the A or B is odd, is our conclusion, Q. All right, so here I'm just going to kind of talk through the reasoning and the content of the proof, and then you can see the notes below for the final write-up. All right, so to prove by contradiction, oops, there we go. All right, to prove by contradiction, we get to assume two things. We get to assume that P is true. All right, so that's exactly how we would start a direct proof of an implication also. And then we also get to suppose that the conclusion Q is false. Okay, so here, what does that mean? So Q says that A is odd or B is odd. Right, so I'm just kind of slightly rewriting that. And if we're assuming that that's false, then we want to do the negation of Q, basically. All right, so I'm going to stick the little negation sign in front. And then I'm going to change the word or to the disjunction symbol. All right, and the reason I'm doing that is because I want to make it clear that in this case, because our conclusion is an or statement, that when we negate that, we need to use De Morgan's laws. Okay, so if we're negating the statement A is odd or B is odd, then remember, we negate each piece separately. So we're negating A is odd, we're negating B is odd. So that would turn into A is even and B is even. A is even, B is even. Okay, but remember that when we negate an or, it becomes an and. All right, so in other words, what we're supposing here is that A is even and B is even. Okay, so these are going to be our two assumptions, right? We're assuming that P is true. We're also assuming that Q is false, which in this case means exactly that A is even and B is even. All right, so now let's get into kind of the proofy part, I guess, if you will. All right, so our assumptions, we're assuming that P is true, which is exactly A squared plus B squared is odd. And then we're also supposing that Q is false, which again, as we just said, means that A is even and B is even. Okay, so where can we go from here? Well, we know we've seen plenty of examples like this where if we know that a number is even or odd, we can kind of go back to the definition for what it means to be either even or odd. Okay, so then we know there exists an integer k such that A is equal to 2k and another integer, I'll call it L, I guess, such that B is equal to 2L. All right, so that's what we know just based on the definition of what it means to be even. All right, and again, I'm not really writing this out in full sentences as a formal proof, just kind of trying to get our thoughts down. All right, so where can we go from here? Well, since we are trying to prove, since we have A squared plus B squared up here in our assumption, and now we know what A is and we know what B is, it would probably make sense to just square each of those and add them together. So we would get A squared is, of course, 2k squared, 2k squared, which would be 4k squared. And then B is 2L, whole thing squared, which is, of course, 4L squared. All right, so then we can add them together. A squared plus B squared equals 4k squared plus 4L squared. All right, but what can we do to that? Well, the greatest common factor there is 4, but I'm really just going to factor out a 2, because if we factor out a 2, notice that all of this stuff in here is an integer. Because k and l are both integers. So if we square them and then multiply them by 2 and add them together, we still have an integer. So then what we really have here is 2 times an integer. So this tells us that a squared plus b squared, what we started with over here, is actually even. Okay, so is that okay? Well, not really, because up here we were assuming that a squared plus b squared is odd. So now we have a contradiction. Okay, so again, I said kind of in the notes that when you start a proof by contradiction, you often don't know what contradiction you're going to get to. In this case, we were assuming that a squared plus b squared is odd, but then we were showing that it's even. So our only logical conclusion is that this statement that we started with, if a squared plus b squared is odd, then a or b is odd, is actually true. So see the notes for the formal write-up of this, but hopefully this gives you a better understanding of the ideas behind it.